Now, in terms of assignments, you've got the lab report that's coming in. That's due tomorrow, okay? Because it was supposed to be due on the Tuesday, the 4th, that date, but it's not. Now it's due tomorrow, okay? You had an extra week to work on it, so you shouldn't have any problem getting that one done. That is it, okay? There's not going to be anything else. I'm not doing the climatogram in-class activity anymore, okay? That's one of the things I'm scratching because we lost a week, okay? So that is the last assignment you will hand in to me for marks, okay? It'll be unit exam, final exam, and that's it. Now, in terms of, being here, as Mrs. O said this morning, we're going to try and wear masks more, okay? I'm going to try and do that. How many of you can hear me at the back? Is my muffled? Is this pretty clear? Okay, all right. So what I've done is put the green box on the floor, okay? The green box is for your safety as much as it is for mine. As long as I don't cross the line, I'm 6 feet from the front row. Okay? That means, though, if you need to talk to me, you have to stand outside the box. I know that seems really petty. And it is. I will not argue with you on that one. It is. Okay? But it's the way it's going to be. Okay? I'm still here to help you. Okay? We can do help up on the smart board. That's no problem. I can still look over your labs and stuff like that. That's no problem either. Okay? That stuff's not going to change. There's just a box on the floor to protect us from each other, because it's not just you guys I see 100 kids every day. Okay, so I've got to make sure I keep you all kind of separated as best I can. Okay, that's also why the desks have been moved back. That was the only way I could create the separation, so I know that's inconvenient. You can't walk behind the rows anymore. It's also inconvenient for me, but okay, that's the way it is. Remember, there's hand sanitizer on the wall. There's also hand sanitizer on top of the filing cabinet. Please make sure you use it often. Okay, whenever you touch something, before you go to your face, whatever, okay, make sure you use the hand sanitizer. There's lots of it, taxpayer funded, okay? Use it all up. Okay, also, if you feel like you're getting sick, stay home. I will start live streaming tomorrow. Okay? So if you are not feeling well and you're not wanting to bring it in here, please don't, okay? Stay home and I'll live stream, and I'll continue to post stuff on Google Classroom as well. So if you're feeling up to it, you can just sit there and watch it from home. If you're not feeling up to it, you can catch up with Google Classroom, okay, and do it that way. That's fine. I don't care either way, but I will provide both. All right, so they will be live stream available. I can't promise that every one of your teachers is going to do that, because everybody's handling this a little bit differently. Okay, everybody's handling it the way they're comfortable with, so there's no right or wrong. Okay, on how everyone else is handling that. Okay. All right. Any questions from you guys? I know the one you really wanted answered was the final exam one, and I don't have answers for that. I'm sorry. Okay. So, first lesson in this unit is about climate. Okay, and this should be fairly familiar. You did climate in like grade 7 science. Okay. So it should be a little bit of review. We're going to go into a little bit more detail about a few things. We're going to talk about climate graphs and how to read them. Even though we're not going to do the activity, it's still a skill we have to be able to look at a climate graph and understand what it's telling us about the climate of that particular area. Okay, so we're going to go over the components of climate, okay, factors that affect climate, okay, the effect of climate on plants, animals, and humans. That's a very, very small part. Okay, and energy inputs and outputs, we probably won't get to that. That's actually the next lesson. Okay, and then obviously understand climatograms or climate graphs is the next thing that will be on there as well. Okay, so if I'm going to describe the climate of an area, what are some things I'm probably going to describe about that area?
The weather.
Okay, let's be a little more specific. Yes, the weather.
Temperature.
Temperature. What else? Like when you look at the weather in the morning, okay, what are the things you want to know? Temperature, whether it's going to rain or snow or hail. Around here,
Wind conditions.
yeah, how windy it's going to be, okay, and one more. There's only 4 components of climate.
Humidity.
Okay, we might want to know humidity. It's actually not one of the components of climate, but it's something we would probably check in the morning.
Light.
Light. When does the sun come up? When does the sun go down? Okay, so right now, like 4:30 p.m. it goes down, and like, what, 8:30 it comes up, something like that. Okay, we're in the short part of the year right now. Okay, so those are our 4 components of climate. So climate is our prevailing weather conditions at a location. It is location specific. Okay, the climate here in Okotoks is different from the climate in, say, Los Angeles. Okay, and that's because the factors that affect climate are going to be different for those 2 locations. Okay, the components of climate we just talked about: temperature, okay, precipitation, light, and wind. Now, when I describe those, I don't give averages. Okay, people get this idea that climate is like the average weather at a location, and it's not. Because if I give you the average weather conditions here in Okotoks, it's not going to seem right to you. Okay, so if I tell you the climate of Okotoks is that the average daytime high temperature is 6 degrees Celsius. There are 12 hours of sun and 12 hours of darkness. The wind prevailingly comes from the southwest at about 25 kilometers per hour, and we get about 1 millimeter of rain per day. Does that describe what the climate is like here? Okay, averages mean nothing when we're talking about climate. If we're going to describe the climate of Okotoks, we're going to say things like the temperature is variable. Okay, there is distinct seasonality in Okotoks. Okay, and what we mean by that is we have a definitive summer and a definitive winter. Spring and fall are, we don't really have those. Right? We kind of go from summer to winter and from winter to summer, but we technically have them. Okay, but what we have is definite changes in our temperature. Okay, we can go to, well, as we saw this summer, 40 degrees, or we can go to minus 40 degrees. Okay, that's where we live. Okay, sometimes the air hurts your face. Okay, and sometimes it cooks it right off. Okay, it depends what time of year it is. Precipitation, we get all kinds, and it's not even. Okay, we don't get a certain amount of precipitation per day. That's ridiculous. All summer long, we hardly got any precipitation at all. Okay, and then we get, snow in the wintertime. Okay, typically in this area, our wettest month is June. Okay, the month in which we get the most precipitation in this area is typically June. July is 2nd. Okay, May is 3rd. Right? Believe it or not, those are our wettest months. Okay. Now I know you're probably all thinking, yeah, but Codere, like in the winter we get all this snow. Okay, and it's like deep. Yes, it is. But what you have to remember about snow is this: to get 1 centimeter of rain equivalent water requires 10 centimeters of snow. Okay, so if you see 10 centimeters of snow on the ground, that's the equivalent of 1 centimeter of rain. Okay, that's why we don't get a snowfall warning unless there's going to be 5 to 10 or more centimeters of snow, because that's going to be the rainwater equivalent of a heavy rainfall. We don't get those warnings usually unless we're going to get 10 millimeters of rain or more, okay, in a short period of time. Everybody follow me on that? Okay, so it's hard to always understand that, yeah, this much snow actually doesn't represent all that much water. Okay, if I got 20 centimeters of snow, it's this much water. Okay, there's a lot of air spaces in snow. That's what makes it such a good insulator. Okay. All right, in terms of light, okay, I said when we were doing the averages, we get 12 hours of sunlight and 12 hours of darkness. That's true. I could say that anywhere on Earth, and it would be true. Okay, but day length changes throughout the year. We know that. We're in the shortest days of the year right now, okay, and we are headed towards the longest days of the year. Okay, and so what happens then is, because we get more direct sun and more hours of it, the temperature goes up. Okay, so sunlight, the amount of light we receive does change. Now, if you live near the equator, is that true? Oh, okay. I remember going to Hawaii once, and this lady who was at the front desk, she was complaining about how short the days were getting. It was like August. And I'm like, what do you mean, how short the days are getting? Like, the day length doesn't change here. It's like, yeah, but, you know, like, it's, you know, we're headed for December, and in December we only get like 11 hours. Kidding me? Like, come up to Canada on December 21st and live through a 4-hour day, okay? Like, you have no idea. Okay, on the other side of that, we have parts of the year where we get 18 hours of sunshine, okay? Or if you go even further north, the sun doesn't go down for a month, okay? It's great if you're a kid and your mom tells you come home at sundown, you come home a month late, okay? But it's true. Because of the Earth's tilt, okay, day length here changes, and that has a big effect on our planet. Okay? At the equator, it never changes. That also has a big effect on its climate. Okay? There's no distinct seasons other than like rainy and dry at the equator. Temperature-wise, their temperature doesn't fluctuate. Okay? All right, questions so far? All right, so all of these are our 4 components. Okay, we got to remember these. The factors can change these components, so we got to make sure we understand the difference. These are the things that make up climate. Now we're going to talk about the things that affect these 4 things. Okay, everybody all right with that idea? Okay, what's going on in this picture? What's building there? Usually see them in the summertime. We didn't get many this year though.
Like rain clouds?
Yeah, what kind of rain clouds? Grade 7 science, your meteorology unit. Cumulonimbus, right? Okay, the thunderheads. So these represent kind of an interaction of all of the components and factors of climate. Okay, so if we have the right conditions to build these, which we usually do in June and July when we get the majority of them, okay, we have usually a hot, humid, still day. Okay, so we're looking at temperature has to be right. Right? Light's got to be right. We got to have energy coming in to build these. There can't be very much wind, and it's going to cause a lot of this. Okay, it's going to cause a lot of precipitation. So what ends up happening with a thunderhead is you get water evaporating, okay, and heading upwards. Now, as air goes up, what happens to it? As you go up in altitude, what happens to temperature?
It's cold.
It's cold. Okay? On average, about 6.5 degrees every 1,000 meters. So as this warm, humid air moves upwards, okay, it cools and the water vapor in it condenses and tries to fall back down. But on a day where you're building a thunderhead, you have so much heavy, wet air moving upwards that it can actually keep the droplets from falling back down. And it'll push them back up. And so what happens is you get a cycle where hot air is moving upwards and then rain and cool air tries to fall back down, but because there's so much warm air moving upwards, it gets pushed back up. And so it'll go through a cycle where it goes higher and higher and higher, which is why throughout the day we see these clouds get taller and taller and taller. Okay? And sometimes they'll even kind of get flat on the top. Okay? If they're getting flat on the top, they're usually running into a layer of air above them. Okay? And what's usually happened at that point is these water droplets have tried to fall back down, but they've been pushed back up. More water droplets condense, and so the droplets go from being really, really small to being bigger. Okay? The more times they go through this cycle, the bigger the raindrops get. If they go through this cycle enough times and go high enough, the rain freezes and turns into what can come out of these sometimes? Hail. Yeah. Okay. Now the cycle for building hail is exactly the same. The hailstone falls back down, but there's enough warm air going upwards that it can get pushed back through this cycle again. Okay? More water vapor will freeze onto the outside of the hailstone, making it get bigger and bigger. Okay? Next time it hails, after the hail is done, don't go out in the hail, especially if it's big. Okay? Go out and get a hailstone and break it. And you can actually see it looks like an onion on the inside. It'll have layers. okay, where you can see the deposition of more and more ice onto the hailstone as it grows. Now, you're not going to see that in one of those little ones, okay? But if we get the golf ball size ones, and we pretty much always do, okay, at some point, you can see it in those. Okay? If you break one open, you can actually see the layers itself. Okay, questions on how that works? Okay, so factors that affect climate. The biggest factor affecting climate is latitude. Where you are in relation to the equator, okay, determines the intensity and amount of solar radiation you receive. The more intense the solar radiation, the higher the temperature. All right, so if I am at the equator, okay, and we're saying that all parts of the Earth receive the same amount of solar radiation, okay, we're saying that at the equator, that solar radiation is concentrated in an area the length of this red line. Because the Earth is curved and tilted, that same amount of solar radiation, when it hits an area further north, is now spread out over a greater area. Okay, you can see it doesn't actually touch now both sides of the beam. Okay, and the situation worsens the further north you go. Okay, sunlight becomes less direct because you're not right underneath. Okay? Now, the Earth actually only looks like this, straight up and down, 2 days a year. Which 2 days? I'll give you a hint. These are the 2 days of the year where day length and night length are exactly the same everywhere on Earth. The opposite. Equinoxes. Okay? The winter equinox and the spring equinox. Sorry, not winter, sorry. The fall equinox and the spring equinox are the 2 days of the year where the Earth is essentially straight up and down, and everywhere on Earth has 12 hours of sun and 12 hours of day of night. Okay? Now, on that day, we still get less intense sunshine than the equator does because the sun is not directly overhead. Okay? Which is why it's typically cooler here than it is at the equator. This situation worsens after the fall equinox. Okay? What does the Earth start to do? It starts to tilt. See, the Earth actually does this. Okay? Through its orbit. Tilts back and forth. Okay? So, as we move into winter, the tilt of the Earth starts so that the North Pole tilts away from the sun. Okay? And so now, instead of having this much solar radiation hit us, now the Earth tilts like this. 23.5 degrees from vertical. That's a lot. Okay? It's more than a quarter of the way to vertical. Or to horizontal, sorry. Okay? So it tilts a long way. So now, instead of being here, we're way up here. Okay? So how much time do we spend in the sunshine if the Earth is rotating around its axis this way? The days get shorter because as we rotate around, we only get into the sun for a short period of time. Okay? This is what we call the terminator. It's got a great name. Okay? But it's where night and day meet. Okay? So if we're rotating around the axis this way, we only get into the sun for a few hours and we spend more hours in darkness. As we move towards summer, the Earth tilts this way. Okay? And now we spend way more time in the sun. And actually at the North Pole, the sun never sets. Because the pole is pointed towards the sun, okay, and it never gets into the darkness. Okay? I don't know if anyone's has ever been above the Arctic Circle on in the summertime, but it looks really weird. You can actually watch the sun go around in a circle throughout the day. Okay? Throughout a 24-hour period. It won't set, but it'll do this. Okay? It's not actually the sun that's doing it, it's that we're rotating underneath it. Okay? But it won't go down. Okay? And similarly, if you've ever noticed this, or you will notice it now, okay? But right now, the sun comes and does this really weak little arc. Okay, it rises kind of over there in the southeast and sets right over there in the southwest. In the summertime, when we're tilted towards it, it actually rises and sets up here, northeast and northwest, and stays above us much more. Okay, and we get more direct sunshine because it's more directly overhead. Okay, is that making sense? Okay, we do a lot of kind of passive energy capturing using that idea. Okay, we want to put things on south-exposed faces because they're always going to have exposure to the sun, okay, because the sun is typically in the south in the wintertime, okay, and we can capture more passive solar radiation, things like that. Okay, so where you are, your latitude, determines how much solar radiation you receive, and it determines how long or how much your days change throughout the year. Okay, but it all determines essentially your input of solar radiation. Okay, so is latitude super important? Okay. On a test, this is how I would ask about factors affecting climate. I would give you a location that you're familiar with somewhere in Canada. Okay, and I would say, tell me why or describe the climate at this location based on factors that affect climate. So if it was Okotoks, okay, you would tell me about how we're quite far from the equator, and that would change how much daylight we would receive and the intensity of the sunshine and blah, blah, blah. Okay, you tell me about things like altitude and the other factors that we're going to go over. Okay, and you tell me how they affect our temperature, our light, our precipitation, and our wind. Okay, and you have to be able to do that for basically anywhere. Okay, so you have to know the 4 components and at least some of the factors so that you could answer that question. Okay, that sort of makes sense? All right, second most important factor affecting climate is your altitude. Okay, as we said a minute ago, the higher up you go, the colder it gets. On average, 6.5 degrees Celsius for every 1,000 meters in elevation that you gain. Okay, that's why the mountains have snow on them until midway through the summer. Okay. So, if I am looking at, let's say, Calgary versus, no, let's not even say Calgary, let's say Canmore versus Calgary. Which one's going to be colder? Canmore. Okay, why? Canmore is several hundred meters higher, okay, than Calgary is. Okay, the snow persists there for longer, okay, things like that. Everybody all right with that one? Okay. So if I'm comparing 2 cities and one of them is at sea level and the other is, at 1,100 meters, because that's what we're at, okay, the one that's at 1,100 meters is typically going to be colder. Okay, so incidentally, that is our altitude here. Okay, right here in this school, 1,096 meters above sea level. Okay, so you are over 1 vertical kilometer higher here than you would be if you were in Vancouver. Yeah. Weird to think about it, but that's how much higher we are, okay, than sea level here. Okay, other factors. Distribution of land and sea. So how close you are to an ocean can affect your climate. Okay, perfect example, Calgary versus Vancouver. Their latitudes are almost identical. We're about the same distance from the equator. Obviously, Vancouver's 1,000 meters lower, okay, in elevation, but it's considerably warmer. I mean, how often does it snow in Vancouver? Not often. Okay, it's typically around. Even in the coldest parts of the year, it rarely drops below freezing. Okay? If it does drop below freezing and snows in Vancouver, like the whole city shuts down. Okay? Like nobody has winter tires, there's no snow plows, okay, stuff like that. Like it's just, everything just has to shut down because it's just not something that happens very often. And that's because they're close to the ocean. Now, the ocean can help to balance changes in air temperature. The reason it can do that is water has what we call a very high heat capacity. That is, it can gain or lose a lot of energy, but not change temperature very much. Okay? So if, kind of like what happened here over Christmas, a really cold Arctic air mass moves down, okay, polar vortex drops down, you get all this wickedly cold polar air coming in. It gets really cold here because we've got nothing to regulate that. But in Vancouver, which also experienced the polar vortex, okay, the temperatures don't drop as much because the ocean, okay, will have energy coming out of it into the air. Second law of thermodynamics, right? Energy always flows from hot to cold. Well, when the air temperature drops below the temperature of the ocean, heat comes out of the ocean to heat the air, and it helps to regulate the air temperature. Okay? Now, it's still going to get cold. Like we have a polar vortex like we just had. It's going to get cold in Vancouver. It would still feel nice to us because it's not minus 40, okay? But it's still going to be cold for them. Okay? But the ocean really helps to regulate that temperature change. So they don't get the wild fluctuations that we do, right? We can have an 80-degree fluctuation in temperature between winter and summer. Vancouver might have a 25-degree fluctuation between winter and summer. Okay? Now, comparatively, it also doesn't get super hot in Vancouver. It feels hot because it's humid, but it doesn't get like temperature hot. Okay? You rarely have a 40-degree day. Okay? The ocean will also help to regulate the heat part of it. All right? So being near an ocean really helps to regulate the temperature swings. If you're near an ocean, you may also be affected by the nature of the currents that are flowing through that area. Okay, there are lots of ocean currents that are affecting temperature. So you've got your subarctic and Alaskan currents that kind of go past the west coast here. They're typically colder. Okay, colder water currents, which is, how many people have ever been to Vancouver and actually been in the Pacific Ocean? Okay, so the Pacific Ocean in Vancouver is cold. Okay, the Pacific Ocean down even in California is cold. Okay, because there's these Arctic currents. The California current comes off of the subarctic currents, cold water. Okay, if you go onto the east coast, you get warm water currents coming up from the Gulf of Mexico. Okay, and they can affect the temperature differently. If you're in Newfoundland, then you've got the Labrador current that comes by, and parts of the ocean can actually freeze in the wintertime. Okay, it's different ocean currents. Where is it bringing the water from? So on the east coast, you've got water coming from the Arctic Ocean, going out, making the water colder. Okay, here, we say it's cold, but it's actually kind of it's warmer by comparison. Okay, and then of course you've got your Gulf Stream and the North Atlantic current. Okay, those are both warm water currents that come up from the south, so they can affect temperature, humidity, and precipitation. Okay. All right, and then of course we've got El Nino and La Nina, which we always hear about. Okay, this is supposed to be a La Nina year. Okay, we're going to have a long, cold winter because there's an upwelling of cold water off the coast of Chile, which is in South America. When we have an El Nino year, then there's a warm water upwelling off the coast of Chile. And what it can do, those two currents can actually change the global ocean temperature by 1 or 2 degrees. I know that doesn't seem like very much, but when you consider how much water that is, that's a lot of energy. Okay, and that can make for a warmer winter or a colder winter Earth water. Okay, questions so far on that? All right, distribution of mountain barriers. This is one that affects us greatly. Okay, being tucked up against the foothills and against the Rocky Mountains here greatly affects our climate in a couple of ways. Okay, the first thing it does is it makes it quite dry here. Okay. So what happens is water evaporates off the Pacific Ocean and wind typically blows it from west to east. So it blows this warm, moist air off of the Pacific Ocean and against the Rockies. Of course, it can't go through them, so it has to go up and over them. As it goes up, it cools, and all of that humidity and all that water vapor that's trapped in it condenses and falls as precipitation on the western slopes of the Rockies, basically in BC. Okay, so it all falls on BC. By the time it gets up and over the mountains, almost all of the moisture has already been lost. And so now we've got this cold, dry air coming over the mountains. So we don't get nearly as much of the moisture. It's all been lost on the mountains. Now, as that cool, dry air starts to fall down the mountainside, it picks up speed. And as it picks up speed, there's friction between the air and the mountains and the surface of the earth that causes it to warm. Okay? And it comes racing off the mountainside, blowing from the southwest, nice and warm, which we call? Right. Okay? That's how Chinook is born. Okay? We're very familiar with that because it's a huge part of our climate and it's all related to being close to the mountains. If you go to eastern Canada and you say Chinook, anywhere other than Newfoundland, they will have no idea what you're talking about. The only reason the Newfoundlanders know what you're talking about is because half of them moved here to work. Okay? And so they know what a Chinook is because they've lived out here. Okay? But if you go to Ontario and you say Chinook, people don't know what you're talking about. It's a very localized phenomenon. It's hugely important for our climate, but beyond here, you do not see the effects of it. Okay? Does that sort of make sense? Okay? So this is what we call a rain shadow. Okay? A rain shadow is the effect of a mountain range that is essentially stealing the moisture from air masses as they move over top. Okay? So we are in the rain shadow of the Rockies. Arizona is also a rain shadow desert. Okay? The Gobi Desert in Asia, okay, is a rain shadow desert of the Himalayan mountains. All right? So it's not a hot desert. It's a really cold desert, high altitude desert. Okay? But moisture basically doesn't make it over top of the Himalayas. And Mount Everest was 3 times taller than our tallest mountain. Okay? So it's definitely a bigger barrier there than it is here. Okay? And they would experience things similar to Chinooks as well. All right. Everybody okay with that? So if I asked you to describe, the climate of Okotoks and the factors that affect it, would this be one of the things you would mention?
Yeah.
Absolutely. Okay? Like latitude would probably be our first and biggest factor affecting our climate because it is for every city. It doesn't matter what city I tell you, use latitude as the #1 factor, okay, because it affects everybody. Mountain barriers would probably be the second for us. Okay? Altitude probably third. All right? If you were talking about the climate in Charlottetown, PEI, well, you probably wouldn't describe mountain barriers then. Okay? But you'd probably describe proximity to the oceans and ocean currents in place of mountain barriers. Okay? You could also describe that altitude would be much lower because it's basically at sea level. Does that sort of make sense how I would ask that and how you would explain it?
So on a question, if you're asking, say, for Okotoks, you wouldn't really put like the nature of the ocean currents. Like you wouldn't really include that.
No, because ocean currents don't affect us. They do. El Nino and La Nina would affect us, but that's periodic. It's not something that affects us every day. Nature of mountain barriers, that affects us.
So you'd only describe the ones that actually.
Yeah, because the question would probably say, like, name the biggest factors or describe how the factors affecting climate make the climate the way it is, right? And La Nina or El Nino and La Nina don't really affect us regularly. Altitude, latitude, and mountain barriers do. Okay? If we're talking about Charlottetown, well, ocean currents, latitude, and altitude are probably their biggest ones. Or proximity to the ocean. You can pick. Okay? Questions there? All right. Pattern of prevailing winds also can affect your climate. Now, here in Okotoks, in southern Alberta in general, the wind typically comes from the southwest. Okay, which means it typically brings the same kind of air towards us. If the wind direction changes, and we get a wind that's coming from a direction other than the southwest, do we typically get a change in weather? What do you think? Yeah, usually. Okay? If we're getting a wind that's coming out of the northeast, get ready. Okay? Something big is going to happen. All right? If we're getting a north wind, it's going to get cold. Okay? But typically, the wind comes from the southwest here, bringing the usual warmer, drier air. Okay? So, you got your pattern of prevailing winds, and then you've also got your locations of high and low pressure. Okay? And there are some places that are basically always a low pressure area and some places that are basically always a high pressure area. We're not one of those places. Okay? We have a saying in Alberta. If you don't like the weather, wait 5 minutes. Okay? Right? There was like a meme a couple of years ago, and it was like something like, you can't have all 4 seasons in one day. Alberta, hold my beer. Okay, I mean, that's how it is. Okay, we can have all 4 seasons in one day. Right? There's a reason Leonardo DiCaprio thinks that climate change is a thing. It is a thing. It is. I'll admit that it is a thing. Okay, but he talked about how he experienced it in one day. You can't experience climate change in one day, people. Okay, you can experience it over the course of your lifetime, over the course of 10 years, and you will because it's a thing. Okay, it totally is. But you can't experience it in one day. He was up here filming a movie. What did he experience? A Chinook. And it was apparently very scary and life-changing because the temperature went from -20 to +20. Yeah, it happens. Happens all the time here. We don't worry about it. Okay? Is climate change a thing? Yes. Is climate changing? Yes. A Chinook is not climate change. That's called weather. Weather can change. And it can change fast. Okay? He got a lot of heat on that one. And rightfully so. Because he has a lot of social media influence. He made Alberta look really, really bad for all the wrong reasons. Okay? Yeah, so I always give him a hard time when I teach this lesson. A Chinook is not climate change, it's weather change. Okay, climate change is like glaciers shrinking. That's happening. Climate change is weather, like increased rainfall or increased temperature over time. That's happening, absolutely. Okay? But what he saw on that day was not. You gotta know your stuff. Okay, so there are some places where it's typically always low pressure. This area right here, off the coast of northern BC, is what is often called by meteorologists the mother low. Low pressure areas kind of are generated here. It's where they're born. That's why it's called the mother low. Okay, and typically rotation around a low is clockwise. Okay, so what happens is low pressure areas can get thrown off of the mother low, and they'll head that direction. Right here is what's known by meteorologists as the Siberian high. Typically over Nunavut and the Northwest Territories is a high pressure area. Okay, we experienced a high pressure area for like the last 2 weeks. Okay? In the wintertime, a high pressure area creates clear skies and really cold temperatures. Okay? So rotation around a high is opposite. It's counterclockwise. So if a high pressure area containing a lot of cold Arctic air comes off of here and it meets a low pressure area containing lots of warm, moist Pacific air, they meet right here. And create a swath of destruction straight down the side of the Rockies. Right where Highway 2 is. Okay? I mean, we've all driven on Highway 2 when this happens. Okay? Highway 2 just happens to be like the tornado alley of Canada. Okay? And it's because there's a low pressure area here, there's a high pressure area here. They interact. The jet stream often gets pushed around by the Rocky Mountains and directs weather right down along the Rockies, okay? And giving us that ability to have rapid changes in weather. Okay, so if this happens in the wintertime, that's when we get one of the, like a big snowfall warning and we get a dump of a foot of snow. Okay, if this happens in the summertime, that's when we get a big hailstorm. Okay, it can lead to really unstable weather and we'll get into that thunderstorm cycle where it's nice during the day and then there's a big hailstorm at night for like a week. Okay, anyone kind of follow me on that? All right. Now, last thing we got to talk about for this lesson here is climatograms or climate graphs. So a climate graph is a quick visual representation of the climate of an area. Okay, it shows us the patterns of temperature change and rainfall monthly. Okay, so it's showing two things on the same graph. So for this first graph here, this is the climate graph for a tropical rainforest in Papua New Guinea. Okay, so you can see here that we got two things. We got this like column graph or bar graph, and then we also have a line graph. So the line indicates temperature. Okay, so temperature is over here on the right-hand side. Precipitation is represented by the bars, and its scale is on the left-hand side. And then on the x-axis are the months of the year. Okay? So what we can see here is that the temperature in the tropical rainforest basically doesn't what? It doesn't change. Because where are most tropical rainforests? Near the equator, where the amount of sunlight doesn't change throughout the year. They get the same amount of solar radiation, so their temperature doesn't change very much. Okay? What we do see is high, heavy rainfall. Now, they do have a wet and a dry season. Okay? Like this would be the dry season, this would be the wet season. Okay? But typically, their rainfall is quite high. Okay? Their rainfall here in the month of March, okay, is 33 centimeters. Okay? That's that much. Okay? From the bottom to the top here. Okay? That's 33 centimeters of rain in a month. All right? That's a lot. To give you an idea, in 2013, when we had all the big floods, we got this much. Okay? We got 72 millimeters in a couple of days. Okay? That's a lot for here because we're not used to getting that kind of rain that fast. Okay? But if we were to get 33 centimeters in a month here, build an ark and start collecting animals 2 by 2. Okay? Like that would be a ton of rain. Okay? The tropical rainforest is flooded much of the time because of the excessive rainfall.
When we're talking about all this rainfall, is it over like a certain spot or over the entire rainforest?
Well, this climatogram would just be for Manokwari, but that general area would be very similar.
Mm-hmm.
Yeah. Okay, so their driest month is like 11 centimeters of rain, which would be like our wettest month, and a little more. Okay, so quite a bit wetter. Now, the next climatogram here, we can see that the temperature line has formed a bell curve. Okay? Once you start to move away from the equator, you'll see a bell curve temperature pattern, which indicates now there are seasons. You're far enough from the equator that the tilt of the Earth now plays a role in how much solar energy you receive, and thus gives you seasons. Okay, fall, winter, summer, and spring. Okay, so here in Nashville, Tennessee, which would be mid-latitude United States, so about from north to south, about middle. Okay, we see that there is definite seasonality. Okay, in the winter time, the temperature drops down to about 6 degrees Celsius in their coldest month. Okay, and in the summertime, it can be 28 degrees in the summertime. So it's a pretty hot place in the summer, okay, but pretty mild through the winter. They get snow there occasionally, but it doesn't last very long. Okay, but what do we notice about their precipitation? Is it quite a bit lower? It's also fairly even. Okay, like every month of the year gets about the same amount of rain. Okay, and that helps. That really influences what kind of organisms can live there. So Nashville, Tennessee would be in what we would call a mid-latitude deciduous forest. Okay, so there would be lots of trees like oak and hickory and stuff like that that would lose their leaves every year. Okay, simply because they get this nice even rainfall and they have a very temperate climate. Now, go to Anchorage, Alaska. Okay, go to Anchorage, Alaska. You still got the bell curve, but look where it's located. Right? Like it's dropped down significantly from where Nashville would be. And Anchorage, believe it or not, is actually a pretty temperate part of Alaska because it's quite close to the ocean. Okay? So its coldest month, about minus 10 degrees. Its warmest month is only about 14 or 15 degrees. Okay? So quite a bit further north, but definite seasons, because the further away from the equator you get, the bigger the bell curve will be and the lower on the chart it will be. Okay? And we can see here that their rainfall is quite a bit lower and that their wettest part of the year is actually August, September, October. Okay? So basically just be able to look at a climate graph and be able to describe to me what the climate of that area would be like. Okay, later on in the unit we're going to go over biomes, which is like the ecological regions on Earth, and what you'd be expected to do is I give you a climatogram, you tell me which biome it goes with. Okay, so if you saw one like this, you'd say tropical rainforest. If you saw one that looked, let's say like let's say, be a desert, yeah. Okay, it's got, changing temperature, but almost no rainfall, right? Or zero rainfall in a lot of months. Very, very dry place. Okay, so to be able to kind of do that, that's what I would expect you to be able to do. Okay, all right, I want you guys to answer these questions here. I'm going to give you a few minutes, so write down some answers for these, and then we'll go through them together. Okay? Okay, let's quickly talk about these here. So, components to climate, describe them as you think they are in central Alberta, so that would be like north of Red Deer. Okay? So, would light be kind of similar to what it is here? Yeah, it fluctuates, right? They're quite far from the equator, so light would fluctuate. Okay? There would be, long days in the summer, short days in the winter, and the intensity of that light would decrease accordingly. Okay? In terms of precipitation, it's quite a bit wetter in central Alberta. They get more regular rain because they're a little further from the mountains. They get a bit more moisture from the north than we would typically get. Okay, so things do tend to be a bit wetter in that area. Okay, their prevailing winds, they don't really have any. Okay, in central Alberta, the wind direction changes often. Okay? And the simple reason for that is they're a little bit further from the mountains, so they don't get Chinooks. Okay, if you go, up to Red Deer, you very rarely ever get a Chinook up there. Edmonton doesn't get them. Okay, so it's a very different thing up there. Their wind direction is basically based on the movement of pressure changes and things like that. Okay. And then wind. I'm sorry, we talked about wind. We talked about this. Temperature. It's a little bit colder there. Okay, a little bit colder because they're a little bit further north. Okay, they're actually a little lower in altitude, but they're a little bit further north. Okay, number 2, what factors most affect climate in our area? Number 1 would be latitude. That's the right answer for any place. Okay, so as I said before, if I ask you a question like that on a test, latitude is always going to be the right answer. Put latitude down, describe where it is in relation to the equator, and how that affects intensity of light, day length, things like that. Okay, second biggest factor, presence of mountain barriers. We're very close to mountains. That gives us Chinooks. It makes it dry here because water doesn't get over the high altitude of the mountains. And then the last thing would be altitude. Okay, we are 1,100 meters above sea level, and that's going to typically make temperatures cooler here than they would be at a lower altitude. Okay? Those would be our big three. All right, if we're describing the climate of Saudi Arabia in terms of the components that affect components of climate and the factors affecting them, well, their latitude is equatorial. Okay, and so their day length is not going to change very much. They're going to get very high intensity sunshine. The wind direction means that not a lot of moisture is going to be getting to them. So Saudi Arabia is very, very dry and very, very hot. Okay. Did I miss anything? No, I got it right. Okay. Very dry, very hot. Okay, because they're equatorial, because there's not a lot of moisture-laden air masses making it to them. All right. Questions on any of those? Okay.